Okay, in this video, we're going to look about how do we write an ionic equation. So an ionic equation involves the ions that are involved in the particular reaction, and then you'll also have some spectator ions, which means they are the ions that do not participate in the reaction. So the first step that we have to do to write down the ionic equation is that all these compounds, you have to break it down to their ionic form, especially those that are in the aqueous form, because these, when they are in water, they will be ionized to their respective ions. So let's start out to write. Okay, so NaOH, okay, in the aqueous form, when it ionizes, it will be Na plus, OH minus. Okay, then we continue with HCl, so H plus. So for you to be able to do this, you must know what are the individual ions and their charges. Okay, so you get NaCl, but this is also in aqueous. So whenever it is in aqueous form, that means it will dissociate. Okay, now we come to the last one, H2O, and this is in the liquid form. So when it is in the liquid form, you should not split it, just leave it as it is. So here you have your ionic equation. Now in the next step is you have to check out for which ions that go through change and which ions remain the same. So let's look at sodium ion here. On your right hand side, it is the same. It doesn't change because it remains in the aqueous form. And then next one is hydroxide ion, but you don't have any hydroxide ion. Okay, right. Next, hydrogen ion. You also don't have any hydrogen ion. Well, probably because it had already combined with hydroxide to form water molecule here. Okay, and chloride ion, which you see here as well. So now what we do is we cancel out those ions which are exactly the same. So in this case, we will cut off the sodium. And then we will cut off the chloride ion. So these are your spectator ions. The one that you cut off are your spectator ions because they do not participate in the reaction. So in the end, what you have is actually this. So this is called your net ionic equation, and for neutralization, this will always be the case. For any acid or any alkali, you will always have this as your ionic equation because these are the ions that will actually participate in the reaction.